Good day, the topic is manometers. For its definition, it is used to estimate the value of gauge pressure. So it is a tube, either made of plastic, metal, or glass, with fluids with known specific gravities. So the surface at which moves proportionally with changes of pressure. Simple example of application of manometer is applying vacuum pressure to drink a soda using a straw. For major types of manometers, first is the open type. So for the open type, one or both leg or legs is or are exposed to the atmosphere. So if one leg is open, it is capable of measuring gauge pressure. For example, a piezometer. So for open type, with both legs open, for example, YouTube manometer, as shown in the figure, it is used to identify a known specific gravity of fluids. Second type is the differential type. So both legs are attached to either pipes or tanks or combination of the two to determine the difference of pressure. So the figure shows a manometer attached to two pipes, pipe A and pipe B. For the process, first, number in series the interface of fluids and ends of the manometer. So for our notes, for open type, better to start at the surface of the fluid exposed to the atmosphere. And for the differential type, you may start at any end of the manometer. So for this sample diagram, start at the free surface. Number with 1, 2, 3, 4, up to 5, in which that is the end of the manometer. Second, identify points or layers with same elevation and label with same number. The criteria are, first, same number must be same fluid, that is either above or below. And second, within the manometer or the connection part is only one fluid. Then let us check per point. So for this sample, let's start with point 1. It intersects same fluid, that is fluid B, but there are two liquids within the manometer. So we have fluid B and fluid C, therefore not qualified. Next is point 2. It intersects same fluid. So above, that is fluid B. But there are two liquids within the manometer. So again, we have fluid B and fluid C. Therefore not qualified. Next is point 3. So for point 3, it intersects same fluid. So that is below, we have fluid C. And only one fluid within the manometer. Therefore, qualified, and mark the other end as same point, that is point number 3. Next is point 4. It intersects same fluid and only one fluid within the manometer. So that is fluid B only. Therefore, qualified, and mark the other end as the same point, point number 4. Last is point 5. And for point 5, it failed to satisfy the two criteria. So what does this mean? Within the scope of manometer, with same fluid, the changes in pressure are equal. So we have an upward and we have a downward pressure. Therefore, so if we have the upward and downward with same intensity, so we may already disregard these portions. So for process 3, apply the equation that is P sub 1 plus or minus the sum of P sub Li equal to P sub n, wherein P1 is the first point, P sub n is the last point, and what is this plus or minus P sub L? So we will consider plus pressure of liquid if downward direction. And it is inspired by the increasing pressure principle. So as you go deeper, the pressure increases. And on the other hand, that is minus or negative PL if upward direction. Because from a certain depth, if you intend to move closer to the free surface, the pressure decreases, or otherwise relieving pressure. So apply now and start at point 1. So from 1 to 2, the direction is downward. Therefore, it is positive. Next, from 2 to 3, the direction is downward. Therefore, still that is positive. Next, transfer to point 3 at the other leg of the manometer. Then, 3 to 4, the direction is upward. Therefore, it is negative. Then transfer to point 4 at the other leg. Then 4 to last point 5, the direction is downward. Therefore, it is positive. Applying the equation for this sample manometer, start at P1 to P sub n, that is 0.5. So, P sub 1 plus P sub b from 1 to 2 plus P sub c from 2 to 3 minus P sub b from 3 to 4 and plus P sub a from 4 to 5 equal to the last point, that is P sub 5. But for end or ends exposed to the atmosphere or free surface, the pressure is 0. For this sample, P1 is exposed to the atmosphere, therefore P1 is equal to 0. So let's consider our sample problems. So for problem number 1, we are given an open type manometer. The requirement is pressure at the center of the pipe. For the solution, number in series starting at the free end until the end of the manometer, that is the center of the pipe. Identify points with same pressure and eliminate the portion with same fluid pressure impact. Identify the direction of pressure contributions. So for 1 to 2, that is downward. For 2 to 3, upward. For 3 to 4, upward. Apply the equation, start at P1. So P1 plus or minus the contribution of our liquid pressure equal to the last point or P sub n. Wherein P sub 1 plus the pressure of fluid with specific gravity equal to 1 from 1 to 2 minus pressure of fluid with specific gravity equal to 2 from 2 to 3 minus pressure of fluid with specific gravity equal to 1 from 3 to 4 equal to last point, that is P4. But point 1 is at free surface, therefore equal to 0. P4 is the pressure at the center of the pipe. And replace pressure P with formula, that is gamma times height. And for the gamma, use the equation specific gravity times the unit weight of the reference fluid, which is water. Substitute values and convert the value of H to foot or feet. Therefore, P sub 4 is equal to specific gravity of the fluid, that is 1, multiplied to gamma of water, 62.4, then multiply to the height, that is from 1 to 2, so 30 inches, and convert it to feet. Then minus the specific gravity of the next fluid is 2, multiply to gamma of water, that is 62.4, then multiply to the corresponding depth from 2 to 3, which is 12 inches. Convert to foot. then minus the specific gravity of the next fluid is 1, multiplied to the unit weight of water, that is 62.4 pounds per cubic foot, then multiplied to the corresponding height, that is 6 inches. Convert to foot. The value of P sub 4, or the pressure at the center of the pipe, is 0, which means that there is no pressure inside the pipe. If ever the value is positive, then we have a pressure induced with the fluid inside the pipe. And if it is negative, it means that it is under vacuum. Next, for problem number 2, we are given an open type manometer. The requirement is the pressure at the center of the pipe, or point A. For the solution, number in series starting at the free end until point A. Identify points with same pressure and eliminate the portion with same fluid pressure impact. Identify the direction of pressure contributions for point 1 to 2, that is downward, 2 to 3, again downward, for 3 to 4, that is upward, 4 to 5, downward, and apply the equation starting at point 1. So therefore, we have P1 plus the pressure of water from 1 to 2 plus pressure of mercury from 2 to 3 minus pressure of oil from 3 to 4 plus pressure of water from 4 to 5 equal to the last point, which is 0.5. And for this problem, same as the previous, the value of P1, which is at the free surface, is equal to 0. And P5 is equal to PA. Then, we will now replace P with gamma times H, and gamma of liquids with specific gravity of the liquid times the unit weight of the reference fluid, which is water. Substitute values and convert the values of H, or the height, to meter. Thus, the P sub A is equal to gamma of water, that is 9.81, times the height of water, which is 0.9, plus specific gravity of mercury, that is 13.6, times gamma of water, 9.81, times the height of mercury, which is 0.6. That is from 2 to 3. Next, the specific gravity of oil. So minus specific gravity of oil, which is 0.8, times the unit weight of water, 9.81, times the height of oil from 3 to 4, 1.8. Then plus the unit weight of water, 9.81, times the height of water from 4 to 5, which is 1.5 meter. The value of PA, or pressure at the center of the pipe, is equal to positive 89.4672 kilopascals, which means that positive pressure inside the pipe, and as seen on fluids inside the manometer, all are being pushed by the pressure. So let's take the third sample problem. So we are given a differential type manometer, and we are tasked to identify the difference in pressure. It is either PA minus PB or PB minus PA. So for the solution, number in series is starting at A, or you may opt to select B as well, until the last point. Identify points with same pressure and eliminate the portion with same fluid pressure impact. Identify the direction of pressure contributions for points 1 to 2, that is downward, for 2 to 3, upward, for 3 to 4, upward, and for 4 to 5, downward. Apply equation and start at point 1. Therefore, we have P1 plus the pressure of water from 1 to 2 minus the pressure of mercury from 2 to 3 minus the pressure of liquid with specific gravity 0.68 from 3 to 4 plus pressure of oil from 4 to 5 equal to the last point that is P5. But P1 is equal to PA and P5 is P sub B. Rearrange and replace P with gamma times H and gamma of liquid with specific gravity of the liquid times the unit weight of the reference fluid, that is water. Substitute values and convert the values of H to meter. Thus, PB minus PA is equal to the gamma of water, that is 9.81, times height of water from 1 to 2 is 0.15 meter, minus the specific gravity of mercury, that is 13.6, times unit weight of the reference fluid, 9.81, times the height of mercury from 2 to 3, that is 0.1 meter, minus the specific gravity of the liquid, that is 0.68, times the unit weight of the reference fluid, that is 9.81, times the height of that liquid, which is 0.2 meter, plus the specific gravity of oil, which is 0.86, times the unit weight of reference liquid, that is 9.81, then multiply to the corresponding height of oil, which is 0.15 meter. The value of the difference PB minus PA is negative 11.93877 kilopascals. The negative sign means PA is greater than PB. The sign only indicates what is the governing pressure. Therefore, rearrange for final answer, PA minus PB is equal to positive 11.93877 kilopascals and indicate the relationship that PA is greater than PB. Okay, that's it for the topic manometers. Take care and God bless.